Alright, so what you are looking at is my anchor chart for solving linear equations. So I titled it Solving Linear Equations with the SRS Method. It's not a specific method, I just thought it would be easier for students to memorize an acronym. So the S stands for simplify, R is rearrange, and the S is for solve. Under simplify, I have included eliminating the parentheses with the distributive property, or using it, combining like terms on each side. So under rearrange, I have move the variable terms to one side of the equation and then move the non-variable terms to the other side. And then I put in a reminder to remember that if you do it to one side, you have to do it to the other. So, and then for solve, under the solve, I have isolate the variable to solve. So um, when it comes to the different solutions you can have I have examples for each: one solution, infinite solutions, and no solutions. Um, and under one solution, I did 3 examples. As you can see, um, I went kind of simple to more complicated. Um, this one here doesn't use the distributive property. It actually skips right to R, where you just move the variables. So you subtract 5x from both sides, and then subtract 8 from both sides, and then divide both sides by 5, and you get your answer. In the second one, you do have to start with simplify. So using the distributive property, you get 6x minus 6 is 3x plus 12, and then you move on to rearrange. So you subtract 3x from both sides and add 6 to both sides, and you'll end up with 3x is 18, and you divide both sides by 3, you get x equals 6. And then the other one, I'm not going to explain it, it's a little more complicated. But then for infinite solutions, I essentially, if both sides of the equation are the same, then the solution is unlimited. Anything works for x. So in these 2 examples, you can see that they both end with equal terms, equal non-variable terms, actually, to be specific. And then for the no solution here, this bar is kind of in the way, but if you notice that, you end up getting 2 non-variable terms that do not equal each other, and since they don't equal each other, that means there's no solution. Thanks for listening.